So -2, -3. It's right there. -1, -1. 0, 1. 1, 3. 2, 5. And notice, now I didn't draw perfectly, but it looks like these are somewhat on a straight line, right? And it turns out it is represented by a straight line that goes infinitely in both directions. And you're like, wow, I already learned this a few years ago. Why are you doing that? Well, because I want you to compare that to what comes next. So now we have a polar equation. Now, with polar coordinates, we normally write it as r comma theta. And that might give you the impression that r is the input variable and that theta is actually the output variable. But most of the time, we prefer to write theta as the input variable and y as the output variable. Or excuse me, r in this case is the output variable. And I'll tell you in a moment why that actually makes sense. But first, let's see if we can actually make a table. Now let me make this a little bit bigger so you can see it better. Okay, so if r is my output variable, which is going to be on this side, and theta is my input variable, which is going to be on this side, we can actually look at some points. Now, just so you know, this picture actually shows what was done on the calculator, and we will learn how to use the calculator in just a moment. But first, let's see if we can do it by hand, just like we learned how to graph linear functions by hand long ago. Now, just to make this a little bit easier for now, let's go ahead and use degrees, although in the future I'm going to want you to use radians. Okay, so we're only doing this as a brief introduction, and after that you can make the switch and it shouldn't be too bad. Okay, so here's the deal. If theta equals 0, what is sine of 0? Come on guys, unit circle. What's sine of 0? 0. What's 0 times 4? 0. So you start off with the point 0, 0. Now, we have to pick some numbers for theta. Now, if we're doing this by hand, does it make sense that I'm choosing numbers like 30, 60, 90, 120? Because obviously I can calculate those in my head, right? Just like over here, for choosing values of x, I was thinking just like 0, 1, 2, and then some negative numbers, okay? But in this case, I want to just use numbers that I know from the unit circle, okay? So it makes sense that we're just going to say 30, 60, 90, 120, and so on. Now, 30 degrees. What's sine of 30 degrees? 1/2. What's 1/2 times 4? 2. 60 degrees. What's the sine? Square root of 3 over 2. And if you multiply that by 4, you get approximately 3.46. How about 90 degrees? What's the sine? 1. And 1 times 4 is 4. 120 degrees. Notice that 120 degrees has the same sign as 60 degrees. Think about the unit circle. These 2 points have the same sign, right? Because they have the same vertical component, right? So does it make sense that you get the same value? And by the way, 30 and 150, 30 degrees, 150 degrees, do you see how those also have the same sign? Right? So you also get the same value here. 180 degrees obviously has the same sign as 0 degrees, which is 0. Okay? So basically what happens is you start off at 0, you get bigger and bigger values. When you get to 90 degrees, that's when sine is the biggest, right? But then of course it starts to fall again. Now, let's think about 210 degrees. 210 degrees is here. The sign's going to be negative there, right? Matter of fact, what is the sign of this point? Right, so sine of 210 degrees is negative 1/2. Negative 1/2 times 4 is negative 2. And then hopefully you can keep going if you want. Okay, so obviously you're going to have positive numbers for a while because you're going to have positive signs for a while. Then back to 0. Then you're going to have negative signs for a while. Then back to 0. Then you're going to have positive and so on, right? I mean, you know what that pattern looks like. You've already graphed it before, right? Okay, so the question is, if we were to draw a graph of these points, what would it look like? Let's try. Okay? Now, obviously, we could do this on the calculator. Now, right now you don't know, but I'm going to show you in a moment. But before I show you how to do it on the calculator, I at least want you to think about how you would do it by hand.